Hello, guys. Welcome to Ramta Solutions. Welcome to your lesson on grade 11 and grade 12 physical sciences electrostatics. Yes, it's not a mistake. They are the same for both grades. So, whatever question paper you see for grade 11, even a grade 12 students can use it. Grade 11s, you can use grade 12's question papers, okay? All right. So, today in our exam prep, we're looking at a paper from the Western Cape that was written by the grade 12s for their September 2024 examinations. So without any waste of time, as is a norm with us, when we treat past papers, we read instructions. Remember, all the instructions are important, but I'm going to read just a few that I would like to use during this lesson. Instruction 8. You are advised to use the attached data sheet in case you're forgetting the formulas and the constants. Instruction number 9. Show all formulas and calculation and substitutions in all calculations. Instruction 10. Round off your final numerical answers to a minimum of 2 decimal places. In multi-step calculations, intermediate steps should be rounded off to 4 decimal places. I don't have to add anything. This one is what I always say. It's important. I think all provinces must have this instruction like this. Instruction 11, give brief motivations, discussions, etc. where required. Remember, guys, your physical sciences is your physical sciences doesn't have essay questions, so try to be brief. And the last instruction that I like because a lot of us are struggling with it. Instruction 12. Write neatly and legibly. That's very important. Guys, we need to improve our handwritings. That's very, very important. Okay? That's very, very important. All right, now let's get to the questions. Electrostatics is normally question 7 for grade 12 papers, especially the September and November examinations. Oh yeah, question 7, here is it. So we have 16 minutes to finish this question. So we should be done in 19 minutes. Or rather, at time 19, we should be done. But let's go. Vraag 7. The diagram below shows two small identical metal spheres R and S, each placed on a wooden stand in a vacuum. Spheres R and S carry charges of 6 microcoulombs and positive 2 microcoulombs respectively. Spheres R and S are brought into contact for a while and then separated by a distance of 8 millimeters between their centers. 7.1. Which sphere loses electron? Write down R or S. One that loses electron is the one that becomes one that loses electrons. What is happening? The one that loses electrons is the one that becomes more positive. All right, it is one that becomes more positive. Okay, one that becomes more positive. Okay, one that becomes more positive loses electrons. Okay, one that becomes more positive loses electrons. So when they are brought into contact, remember, when they are brought into contact, the new charge will be the average. All right, so 6 plus 2 will be 8 divided by 2, it will be 4. So this one will now have 4 microcoulombs. Therefore, it will be sphere S. Okay? It will be sphere S. That's your answer. Remember, the reason we are watching this video is to help you understand the answers that you are getting, or the answers perhaps that your memo is giving you. Okay? All right. Draw the electric field patterns due to spheres R and S. So there is a repulsion between these, right? There is a repulsion. So for R, there is a repulsion. Even so for S, remember guys, I'm saying there is a repulsion, right? So repulsion, both are positive, so they are going outwards. But remember, there is repulsion. Okay, there is repulsion. Okay, hence you can see they are not in contact. Okay, or they are not joined. 7.3, calculate the new charge on sphere S after contact with R. So the new charge, this formula, I'm not sure if it's given. Let me check quickly. Electrostatics. Can you see it's not given? All right. So this new charge is equal to old plus old first and old second. So one, let's call it R. It's 6 microcoulombs, and the other one is S with 2 microcoulombs. So this is 8. 8 over 2 is 4. I mean, 8 over 4 is 4. So our answer is 4 microcoulombs. So the new charge of sphere S will be 4 microcoulombs. Okay. 7.4, calculate the number of electrons. Calculate the number of electrons transferred during contact. So the number of electrons transferred during contact. You need to understand this. There is a change in the charge. So let's perhaps begin with the change in the charge. It will be, I'm going to say final minus initial, and I'm referring to sphere S. Okay. Even if you take sphere R, it's okay, but I'm going to take sphere S. Finally, sphere S has 4 coulombs. Initially, it had 2 coulombs. Therefore, this is now 2 microcoulombs. Sorry, not 2 coulombs, microcoulombs. So now the new charge is 2 microcoulombs. So this will help us to know the number of electrons that were transferred during contact. Okay. Otherwise, guys, you could have done this bits by bits by saying number of electrons before contact and number of electrons after contact and find the difference between the two. Okay. Now we then say this is equal to over charge of an electron. Okay. But this Q, we're going to make it change in Q. So what is this? It's going to be 2 times 10 to the negative 6 over charge of an electron is given. It's 1.6 times 10 to the negative 90. Okay. Let's go to root of 6 over 1.6. So what is this? This is 1.25 times 10 to the 13 electrons. Ooh, 13 electrons. So these are the number of electrons that were transferred. Okay? These were the number of electrons that were transferred. Okay? Is that true? Yes, it's 1.25 times 10 to the 13 electrons that were transferred. Okay? Great. Moving on. 7.5, point X is located 2 millimeters. Did you hear that? Point X is located 2 millimeters to the right of sphere S as shown below. Define the term electric field at a point in width. So 7.5.1, electric field, let me write it. Electric field at a point is the is the force experienced per unit charge at that point. Is the force experienced per unit charge at that point. Okay, force experienced per unit charge at that point. Okay, at that point. All right, you got 7.5.2. Now 7.5.2. This one is interesting. It says now, let's see. Hold on, 7.5.2. Let me begin by saying, I'm gonna say to the right is positive. So to the right is positive. Remember, I'm saying this because these are vector calculations, okay? Now we have the formula E equals K cube over r squared. Calculate the net electric field strength at point X due to spheres R and S after R and S have touched and separated. So meaning now they both have which charge? They both have this charge. Okay, let's go. So we're looking for E net. I want to show you something. So R to point X, R, if you recall, is positively charged. So it means it's going to go to the right. And then again, when you look at S to X, again, it's positively charged. So it's going to go to the right. Okay. It's going to go to the right. All right. So what do we do now? This is basically saying they are like this. Let me see which one has a shorter distance. One with a shorter distance is S. So shorter will be greater. So this is E of and then this one. Okay. All right. Now E net will then become, as you can see, they are in the same direction, plus XR. All right. Now let's see. This is 9 times 10 to the 9. What is the charge of sphere S? The charge of sphere S is, oh, all of them were 4 because it's after contact. And what is the distance? The distance is 2 millimeter. Milli means 10 to the negative 3. Otherwise, 2 divided by 8,000. Okay. Again, it was also 4. You guys remember it was also 4. Right? And then this is 8 millimeters. So 8 means again means 10 to the 10 to the negative 3. Okay, please let's fix this. This is 10 to the negative 3. Milli means 10 to the negative 3. Okay, now let's get our answer. Okay, where am I? Okay. Oh, 2 millimeter. I think I made a mistake and I have to fix that mistake, guys. The point R is not 8 millimeters away, but rather 10 millimeters away. As you can see, 8 plus 2, so it's 10 millimeters away. Okay. All right. Okay. Let me confirm. Okay. What do we have? So now we have 9,36 times. Oh, let me see. I forgot I can use 3 decimal place, 3 significant figures. 9,36 times 10 to the 9 Newton per Coulomb. Where is it going? We will say to the right. Okay, we'll say to the right because the answer is positive. So this is our answer. Okay, this is our answer. So guys, this is how you do your or how you get your electrostatics on your full maths. This is how you get them. Okay, this is how you get them. And as you can see, we were done in less than 16 minutes. Mind you, we took about 2 to 3 minutes introducing the lesson. So you can imagine it took less time, right? So yeah, remember guys, because you're watching on YouTube, if this video has been helpful to you, please like it. And you can also subscribe to get future updates, to get notification of future updates. And of course, you can also follow us on your social media platforms. The links to different social media platforms are provided in the description of this video. So with that being said, ours ends here and bye bye.